So x and y don't talk to each other directly. They only talk through a third variable, a parameter t. Okay, so to figure out what a sketch of the graph could look like, we can make a quick table, plug in 0 in for x, then we get 0 in for t, then we get 3 times 0 is 0, 0 minus 4, we get negative 4 for x, we get negative 1 for y. And then try some other values, try some negative, try some positive. Let's plug in 2 in for t, so we get 6 minus 4, so that's 2, that's 9. Let's try a negative 2. We get negative 6 minus 4 is negative 10. Negative 10 minus 1 is negative 11. Maybe t equals 1. So that's going to be negative 1 for x. And then if I plug in 1 over here, 5 minus 1 is 4. So we've got some data points. Negative 4 on the x, negative 1 on the y, put a dot. 2 on the x, 9 on the y, put a dot. Negative 10 on the x, negative 11 on the y, put a dot. Negative 1 on the x, that was negative 4, so this is negative 1 roughly, and then 4 on the y, and put a dot. Okay, should be seeing a straight line. And what can confirm that straight line is if you are to find a Cartesian equation for the curve. So solve for t in either one of these equations, like I'll do it over here. I'm going to add 4 to both sides. I'm going to divide 3 from both sides, so I get t is x plus 4 over 3. Okay, I solve for t. And now I can plug what t is into this equation over here. So we get y equals 5 times t, which is x plus 4 over 3. And then there's still a minus 1 out here. Now it looks kind of weird right now because of the fraction, but look, x is to the first power and it's separated from y. That means this is a straight line equation. So without simplifying any further, this is a Cartesian equation. What portions of the graph are the Cartesian equations traced by the parameterized curve? Everything. There's no funny business. There's no part of the domain of this that doesn't exist here, right? One problem would be is if you could plug in a certain value, if you could get like x equals negative 4 in this graph, but you couldn't get x equals negative 4 in this graph, then that would be a portion that was missing in the Cartesian equation. And then initial and terminal sides, I skipped over this. Look, it goes all the way to negative infinity, all the way to positive infinity, so there's no initial, no terminal points for this graph.